using rectangular window method. Okay, first of all we will design the steps and then we will follow up with an example. Steps in general, we have an desired frequency response which is given. Now we will first step we will calculate its impulse response in time domain by using inverse Fourier transform. That is HDN is equal to 1 upon 2 pi minus pi 2 pi HD e raised to power j omega desired response into our multiplier operator e raised to power j omega n and d omega, and the limits will be minus infinite to infinite, that is discrete time. Okay, after finding this impulse response, we will truncate this response to n samples, because digital filter must have some finite size. So here n is the number of samples which we have take to define the digital filter. Generally we use symmetric arrangement so that center is at 0 and then n varies from minus n minus 1 by 2 to n minus 1 by 2. It means for 11 samples n varies from minus 5 to plus 5, that is centered around origin 0. Okay, then in next step we will pass this response through a window. Pass through window which has a response WHN. Passing through window simply means that multiplying the coefficients of HDN and WHN, multiplying each coefficient. Suppose HDN is 1 1 1 and WHN is 1 2 3, suppose it is 1 4 for example, then multiplication will yields 1 into 1, 4 into 2 8, 3 into 1 3, for example. Okay, next step, after passing through a window, now we have HN. This is discrete and finite number of samples, obviously 11 samples taken in this example. Then applying the Z transform of this HN, Z transform is again a very simple procedure. That is Z transform. As it is symmetric, so we can write Z transform like that, at 0 plus n equal to 1 to n minus 1 by 2, here for example 5, at n z raised to power n plus z minus n. This is hn z raised to power n plus z raised to minus n because it is symmetric around center. Next step, we will have to find frequency response. Frequency response is where we have the from frequency. So to identify frequency response, simply put z is equal to e raised to power j omega in the expression of z. Maybe we have to find the again realizable filter. For that realizable filter, we will multiply by z raised to power minus n minus 1 by 2. Here z is from minus 5 for example, and then hz is multiplied by z raised to power minus n minus 1 by 2. N is obviously some number, n is 11 for example, then it will become z raised to power minus 5. Okay, and then finding this hz, again find the inverse z transform of this hz, and it is the hn is realizable FIR filter